This question is based on the conservation of energy. Okay, let us see what is the question. Monica pulls her daughter Jessie in a bike trailer. The trailer and Jessie together have a mass of 25 kilograms. Monica starts up a 100-meter long slope that's 4-meter high. On the slope, Monica's bike pulls on the trailer with a constant force of 8 newtons. They start out at the bottom of the slope with a speed of 5.3 meters per second. What is their speed at the top of the slope? Okay, suppose if you see this one here, the slope is given. The slope here is, this is the slope. Okay, so the value must be 4 meters. This is 4. Okay, and then distance is equal to 100 meters. And then the force here acting in this the same direction of the displacement, and it is given as 8 newtons. F is equal to 8 newtons. Okay, and then what else is required? Initial velocity is 5.3 meters. Let us write the data. Mass m is equal to 25 kilograms, and then distance is equal to 100 meters, and then height h is equal to 4 meters, and then force F is equal to 8 newtons, and then initial speed Vi is equal to 5.3 meters per second. And then we have to find out, okay, G I will write the gravity G is equal to 9.8 meters per second square. And then we have to find out Vf. Vf is the question mark. Okay. Now, according to law of conservation of energy, for an isolated system, the total energy of the system remains constant. Okay. Here, one more thing we have to consider, the Monica is doing the work. Monica is also within the system. Okay, so the work done by Monica plus the initial energy must be equal to final energy. Initially, the object or the Monica, the system has only kinetic energy. So I will write EI is equal to EF. Okay, EI is equal to EF. Here, one more thing is work done is equal to change in energy. So work done is equal to F dot T. Okay, and then initial energy is, initially the object has, I will write all types of energy first, and then later I will strike off whatever is not there. Okay, so Ki plus Ui plus work done must be equal to Kf plus, I will write Ugi. That is a better representation because gravitational potential energy we have. So Ugi I will write. Okay. Here Ugi is equal to 0 because there is no height here. So we are taking this point as the reference point. So at the reference point, the gravitational potential energy is 0. And then initially the object has the velocity of 5 meters per second. That is why it has the kinetic energy. And then work done, the Monica is pulling the bike up the slope. Okay, therefore the work is done by the Monica. Work done is equal to force into displacement. And then finally, at the end point, the object, that means Monica and the bike has the bike trailer has both the kinetic energy and potential energy because they have climbed a steep hill or whatever it may be. Okay, and then as they are reaching there, they have the velocity, and then final kinetic energy is also there. So I will write the actual values here. UGI is equal to 0, therefore UGI is equal to 0 plus, otherwise I will write like this so that there won't be any confusion. UGI plus KI, so that here I will put 0 plus half MVI square plus F dot D is equal to half mvf square plus mgh. Okay. Now, what I do is, I will multiply both sides, right, like this. UGI is equal to 0. Now, entire thing is clear now. So I multiply both sides with 2. Here also 2. Okay. And then I will divide with m. Here also I divide with m. Okay. Then what happens here? Vi square plus 2f dot d by m is equal to Vf square plus 2gh. Okay, now I have to find out Vf square. Vf I have to find out. So what I do is, I will take 2gh other side. Then what happens? Vf square is equal to Vi square plus 2fd by m minus g 2gh. Okay, now write the values. Vf square is equal to Vi. What is the value of Vi? 5.3 square plus 2 times. What is the force here? Force is given as 8 newtons. So 8 into d is 100 meters divided by mass is 25 kilograms minus 2 into 9.8 into 4. Okay, therefore Vf square is equal to what is the value of this one? 13.69. RVF is equal to square root of 13.69, that is equal to 3.7 meters per second. Okay, here what is happening is, we are taking the entire system as isolated system. So the total energy is conserved, and the total energy is conserved means initial energy must be equal to the final energy. And then here the work is, whatever the work is done by the internal forces will also contribute here, but that will contribute to the total energy, but whatever the initial energy, that must be equal to the final energy, because there are no external forces. We are taking the Monica's bike, and then the slope, etc., entire thing as the isolated system. Okay, so therefore here initially the object is the reference at the reference point. At the reference point, the potential energy, gravitational potential energy will be 0. And then as the bike has the velocity, kinetic energy, and then work done. Work done will also contribute to the energy. No? And moreover, we have one more thing you should remember. Here I am taking the frictionless surface. Therefore, work done by the non-conservative forces, NF, okay, work done by NF, non-conservative forces, is equal to 0. This is work done by the, it means friction. Friction is a non-conservative force, no? Non-conservative force is 0. Okay, I'm taking the frictionless surface. In the absence of the friction, I'm taking, so that the total energy of the system remains constant. Okay, hope this helps. Thank you. Bye-bye.